And welcome back as we continue our cosmic journey. We are now going to go ahead and take an overview of our own planetary system. So let's start by looking at our solar system. Now, surrounding our sun is a complex system of worlds with a wide range of conditions. We have 8 major planets with many dwarf planets around it. We have hundreds of moons and countless smaller objects. Now, thanks largely to visits by our various spacecraft that we've sent into orbit, we can now envision the members of the solar system with their own chemical and geological history. So let's do a little exploring of our solar system just to see a little bit about what it is. Well, the solar system consists of the sun and many small objects. Now, decades of observation and using spacecraft exploration have revealed that most of these objects formed together with the sun around 4.5 billion years ago. So everything is here at relatively the same age. Now, our objects that we are looking at in our solar system represent clumps of material that condense from an enormous cloud of gas and dust. Now, the central part of this cloud obviously became our sun, and a smaller, tiny fraction of the material in the outer parts eventually formed the other objects. In addition to gathering information with powerful new telescopes, we've also sent spacecraft directly to many members of the planetary system. We have flown past, we have orbited, and landed on nearly every planet that we can, returning images of the data that have both dazzled astronomers and the public. And in the process, we've also investigated 2 dwarf planets, hundreds of fascinating moons, 4 different ring systems, a dozen different asteroids, and even several comets. Now, what about mankind themselves? What about our visit to other celestial bodies? And as much as science fiction might like to tell us that, yeah, you can go there, well, the reality is, while satellite exploration has been a very large part of our discovery of our solar system, the only celestial body we've been to besides our own Earth has been the moon. The lunar lander and surface rover from Apollo 15 mission, which are seen here in this image, are just taking a view of one of the places beyond Earth that has been explored directly by humans. And humans that have set foot on the moon actually have returned samples of its surface soil for laboratory analysis. So let's take a quick inventory of some of these objects in space here. So this table shows that most of the mass in the solar system is concentrated sun. 99% of all mass in our solar system actually belongs to the sun. The planet Jupiter is our next biggest contender, and it contains most of the material that is in the sun. And if you look at it, it's much more massive than the other planets combined. It has 0.1% of all mass. And you might hear sometimes theorists say, oh, Jupiter is a failed star. But if you look at the chart here of how much mass is actually in Jupiter and compared to the sun, no, Jupiter is not a failed star. Jupiter is nowhere even near big enough to be considered a failed star. Even if you were to take all the other mass and combine it into Jupiter there, you can see it's still not going to really make that much of a difference in comparison to how much mass is in the sun. So let's talk a little bit about the orbits of the planets. Well, all 8 major planets orbit the sun in roughly the same plane in the same direction. So each of the planets, and most of our dwarf planets, you're going to notice they kind of spin about an axis running through it. In most cases, that direction of rotation is the same as the direction of rotation of the sun. We do have a couple exceptions here when we start looking at other bodies that may not be in this main thing here, because you notice we do have some orbits that aren't quite the same as what we would expect with our main plane, because you notice all the planets here are kind of here in this blue concentric circle, whereas like our dwarf planets have some more unusual behaviors with their orbits. Now, there are some exceptions to the individual planet's rotation. Venus, which actually rotates backward in direction so it actually has a retrograde motion as it rotates. And Uranus actually will spin about its axis, kind of almost on its side. In fact, the Earth even has a bit of a tilt in its axis. But, of course, these are simply just individual quirks about these planets that we have observed. Now, let's first talk about the inner planets. So, the 4 planets close to the sun we refer to as the inner or terrestrial planets. And terrestrial planets are relatively small. And when you look at their composition, you'll see they're primarily composed out of rocks and metal. Yes, you might have other things that do it, but their main thing is going to be rocks and metal. So, like, for example, Earth has a lot of iron inside of it. Now, all of them typically have a solid surface that bears the records of geologic history in forms of things like craters, mountains, and volcanoes. So whether you look at Earth, you look at Mercury, you look at Venus, you look at Mars, you're going to see some of this history here. Now, for example, right here in this picture, we have the pockmarked face of Mercury. This is much more typical of inner planets than something you might see such as Earth. Earth is a little different, and Earth's surface is a little bit younger looking because of things like erosion. Now, when we look at the outer planets, you'll see that their composition is a little different. So our next 4 planets, on top of being much larger, are primarily composed of lighter ices, liquids, and gases. Now, these 4 planets, so Jupiter, Saturn, Uranus, and Neptune, are often referred to as the Jovian planets, or you might hear the giant planets, or gas giants. And just for a context of how much bigger these are, if you had 1,300 Earths, you could fit those inside Jupiter, and that's just how much bigger in mass Jupiter is. Now, one thing to note is that all these planets don't have a solid surface. So you couldn't go to, let's say, Neptune and try to land on the surface of Neptune because, guess what? They're primarily composed of gas. Instead, a good way to think about them is vast spherical oceans with much smaller, denser cores. And if we look at Pluto and beyond, because there are the dwarf planets that we should mention here, near the outer edge of our system lies Pluto, which of course is the first of the distant icy worlds to be discovered beyond Neptune. Pluto is an example of a dwarf planet, and is also an example of what we call a trans-Neptunian object, or you might sometimes refer to as a TNO. And all that simply refers to is that its orbit of where it exists is beyond the orbit of Neptune. There is, of course, an asteroid, Ceres, which is also considered a dwarf planet, and that one, though, is not a trans-Neptunian object because you find it in the asteroid belt. Now, let's talk about moons. Now, most of the planets in our solar system are accompanied by one or more moons. In fact, the only planets that don't have moons are Mercury and Venus. They kind of operate on their own. Now, there are currently more than 290 known moons orbiting planets and dwarf planets, and undoubtedly many other small ones remain undiscovered. Now, the largest of the moons are as big as small planets. In fact, our own moon is quite large in comparison to other planets such as Mercury. Now, in addition to our moon, they include the 4 largest moons of Jupiter, which are referred to as the Galilean moons, and the largest moons of Saturn and Neptune, referred to as Titan and Triton, respectively. Now, another cool feature of our solar system is planetary rings. Now, each of the gas giants that exist, they also have rings made up of countless small bodies, all orbiting typically around the equator of the planet. Now, the brightest rings of Saturn are by far the easiest to see. In fact, it's one of Saturn's kind of distinct defining features. And it is one of the most beautiful sights in our solar system. Now, all 4 ring systems, whether you're on Jupiter, you're on Uranus, Neptune, Saturn, they're very interesting for a scientist because they're complicated forms. It's this very thin disk orbiting the spherical body. And these disks are actually influenced by the pull of also the moons that are around these planets. So it is a very interesting relationship because it's not simply just the planet that's creating this ring, but it's also going to be the moons exerting their own influence. And of course, we also have asteroids in our solar system. Asteroids are simply just rocky bodies that orbit the sun, kind of like miniature planets. In fact, some are dwarf planets, as I already mentioned, and these are typically found mostly in the space between Mars and Jupiter. Now, most asteroids are remnants of the initial population of our solar system that existed before the planets themselves formed. And some of the smallest moons that are in our solar system, such as the moons of Mars, are very likely actually captured asteroids instead of other bodies that might have been formed. In fact, that's why it's theorized, because Mars moons are very unusual in shape, that they very well could be. Now, we also have comets in our solar system. And comets are small bodies composed mostly of ice and frozen gases such as water, carbon dioxide, and carbon monoxide. Comets are also a remnant, just like asteroids, from the formation of the solar system, but they were formed and continue, with rare exceptions, to orbit the sun in the distant, cooler regions of our solar system. This cooler region also happens to be the realm of the larger icy worlds that we refer to again as dwarf planets, such as Pluto. Now, there are smaller members of the solar system. One of these things is the cosmic dust. There's countless grains of things like broken rock and ice and stuff like that we refer to as cosmic dust that's scattered throughout our solar system. Now, when these particles of cosmic dust enter Earth's atmosphere, they burn up from the heat and friction, producing a brief flash of light in the night sky, which we refer to as a meteor. Now, occasionally there is some larger chunk of either rocky or metallic material that survives its passage through the atmosphere and actually lands on Earth. Now, any piece of meteor that would strike the Earth is referred to as a meteorite. All right, and of course we need to, now that we have all these pieces, let's just talk briefly about the scale of the solar system. Now, astronomy often deals with dimension distances that exceed our ordinary experiences. For example, what does 1.4 billion kilometers, which is the distance from the Sun to Saturn, really mean? And we've seen some of this already, like when we started looking at how long it takes light to travel from the Sun to the Earth. So let's put this context for you. So let's just imagine for a minute that the Earth was the size of a grape. That means the Moon is the size of a pea and orbits away from the Earth at about 40 centimeters. Now the Sun is about 1.5 meters diameter. The Earth orbits it at 150 meters, or about one city block. To give you some context of where we might find some of our other planets, Jupiter is about 5 blocks away and is about the size of grapefruit. And if we want to peel even further back, we can see Saturn at 10 blocks, and Uranus at 20, and Neptune at 30 blocks. Now, if we kept this same model, just to give you some idea of how vast space is here, the nearest star to the Sun would still be tens of thousands of kilometers away.